In last week's homework, I had you work out the derivatives to a bunch of common polynomials, and I asked you while you were doing it to see if you can spot any patterns in the results versus looking at the original functions, and see if you could start to devise some sort of rule to look at a polynomial and anticipate what its derivative would be. And I hope you were able to do that. We'll talk a little bit about those rules in the next video, but the idea is that if you aren't able to now, then in the very near future, you are going to be able to very easily, 4x is going to be 4, 2x minus 3 is going to be 2, 3x squared is going to be 6x. This is going to be 2x minus 3, and this is going to be 4x cubed. All right, and the rules for this are things that I will talk about in this video, but I don't regret putting you through the work of calculating the limits, because recognizing that the rules for derivatives aren't something that was handed to us on a stone tablet 3,000 years ago, like some things in math feel like they were. But derivatives are something that solve the problem of instantaneous velocity, which is a problem that is both interesting and important. We'll talk about a number of the applications of this either later this week or next week. So being able to recognize that finding the derivative is an example of a limit problem that involves some limit knowledge and some algebra knowledge is important information for you to have locked inside your head. So that's why we took a little bit of time to actually calculate these limits. But I want to talk to you here about some of the derivative rules. And this is going to be the derivative cheat sheet that I am going to link us to. Where's my document camera? There we go. All right, so here is the calculus page for derivatives and limits. All right, so I'm just going to give you a quick tour of this page. Some of this is more important than others, but we're starting off with the definition of the derivative, which is something that we talked about in the last couple of weeks. The basic properties, here are the things that I hope you kind of noticed that made it really easy for me to calculate these derivatives. First of all, if you've got a function that you're multiplying by some constant value c, for instance, if I want to find the derivative of 3x squared, what I do is I take the derivative of I kind of ignore the coefficient for a moment. I take the derivative of the function and then I multiply that back by the coefficient. So I ignore the coefficient for a second and then I multiply it back to my answer. So if I want to find the derivative of this, the derivative of x squared is 2x, and 2x times 3 gives me 6x. All right, so that's what we call the constant multiple rule. Another thing you probably noticed is that if we were adding or subtracting two terms and we knew the derivatives of each of those terms, we would just take the derivative of each one of those functions and then add it together. So for instance, well, let's look at this third rule as well. And this third rule is something we've already talked about, that the derivative of any constant function is equal to 0. So for instance, if we wanted to find the derivative of x squared minus 3x plus 7, the derivative of x squared is 2x minus the derivative of 3x is 3, and the derivative of 7 is 0. So we drop that off. All right. Let's look down through here at the next part of the page. The mean value theorem we'll get to in a couple of weeks. The product rule and the quotient rule are going to give us rules for if we're multiplying two functions together or dividing two functions together. And we want to take the derivative of those functions, and we know the derivative of each of the two pieces. So we're going to see applications of the product rule and the quotient rule later this week and into next week. The power rule is the last of the rules that I hope you kind of anticipated in the video. For instance, if you did all the work on x to the fourth power, what you find, and we did the same thing when we took the derivative of x cubed and x squared, is that you take the exponent and you make it your coefficient, and then you decrease your exponent by 1. So the derivative of x to the fourth would be 4 times x cubed. The derivative of x to the 17th power would be what? Well, you're going to multiply, your 17 is going to come down to the coefficient, and then you're going to decrease the exponent by 1. So that's all you need to do in order to find the derivative of a simple term. All right, and so what we were doing basically in that worksheet is combining the power rule and these 3 basic properties up here. And using that, you can find the derivative of any polynomial super easily. The chain rule is talking about how to find the derivative of functions if we're composing them together. We're going to talk more about composition. It's one of those topics that we probably kind of glossed over. Maybe you hit it at the very beginning of functions. Maybe we can remember how we talked about it a little bit during Algebra 2, but yeah, we'll go over it again. Limit evaluation method, factor and cancel. This is what we were doing in Unit 1 when this would evaluate to 0 over 0. So we had to find that common factor of x plus 3 and cancel it out. L'Hopital's rule is an extra limit rule. We will talk about this later. Over here are a bunch of common derivatives. So basically, this is talking about the derivatives of trig functions, inverse trig functions, exponential functions, and logarithmic functions. We will talk about those over the next couple weeks. One of the sad and slightly scary things about the AP exam is that there is no reference table in the AP exam. So we're going to remember these rules. It's less imposing than it looks like at the moment. We'll have plenty of practice, and it'll come to us, I think. The chain rule and other examples, this is something that we will pretty much ignore. It's just basically applying the chain rule to this list over here. So this is not really giving any new information. Properties of limits, this is pretty much what we were talking about in Unit 1, what I called Rule 1, that same thing, we've got the constant factor rule. If we're adding or subtracting limits, we just add or subtract what the limits of the individual pieces are. Same for multiplication and division and exponents, as long as you're not dividing by 0. And all of this is kind of combined to what I called Rule 1, that if you can just substitute A into one of these things and get an answer, then the rest of it is just straight arithmetic. The last thing was limit evaluations at plus or minus infinity. Some of these things are Rule 2 and Rule 3. A couple other things like talking about exponential functions and logarithmic functions, we will talk about when we discuss exponential and logarithmic derivatives. Okay, so this is going to be one of the pages that I'm going to link kind of above the weeks, because we might come back and reference this throughout the year. If you want to print this out, print that page out and, put it up on your bedroom wall or something like that, especially the parts that you are going to need to memorize, that might be something you'd want to do. But having this with you while you do homework in the future is something that is going to be of great benefit to you. So the purpose of this video, just once again, is to talk about those basic properties of limits that you were able to hopefully anticipate from doing this homework assignment, and kind of anticipating what we're going to do in the near future, talking about the product rule, the quotient rule, and then getting into the chain rule.